It's like what was the problem that originally motivated this? Like why was like URL state management important to you?
I think the initial use case that I had was on my website. I use my website as a sort of laboratory for lots of little experiments. And one of them was a calculator for dovetail joints. So I learned woodworking during the pandemic. And I wanted to have this little calculator where I could design the joints on my laptop and have an SVG rendering of what it would look like, have all the measurements laid out. And when I wanted to go to the workshop to do the actual cutting, I didn't want to bring my laptop with me because it's a lot of dust and all. So I wanted to transfer that to my phone. And I was like, I could just copy paste, put in a note, something like that. But what if I could have the actual application running on my phone as well? And how do I transfer things between that? I don't want to have a server somewhere that I send the data to and save a project or something like that. I'll just put it in the URL because it's convenient. I can copy it. I can load it on the other side. That's fine. And this is actually how it started. And I had this little app that I actually never used to cut any dovetails with, but it was like the starting point for this thing, and it needed a lot of different things that I think became the core of what is now Nuqs. It needed values, which were numbers, not just strings. So the type safety part. How do we transform the query string, which is a string, into data types that are meaningful for our application? And because there were sliders, I don't know if you've tried, but if you connect a slider directly to updating the URL, if you move it too fast, after 10 seconds, your application will crash because browsers rate limit URL updates and they will throw an error if you call it too fast. And so I ended up in this problem very quickly because I like tinkering with everything that I build. And this is like the first step that Nuqs took into becoming time safe rather than type safe. Well, also being type safe, but also being time safe. That's a concept, time safety, that is essentially makes sure that your application will work no matter what you're trying to do with it, at what state you're trying to update and what UI you connect it to. So we have this throttle queue internally, which deals with queuing updates to the URL and then feeding them to the browser at a rate that it will accept, because not all browsers actually work at the same rate. Like Safari and Firefox would be happy with an update every 50 milliseconds, for example. But Chrome and Firefox are happy with 50 milliseconds. Safari needs about 120 milliseconds between updates to be safe. So that's much slower. And you need to account for this because you don't know what browsers people will be on. And if you just throttle at the maximum rate, then your URL is less responsive when it could be more. So this is like a little bit of this time engine in Nuqs that deals with that. And we just recently shipped 2.5, which adds debounce on top of this throttle queue. So you can now schedule updates further in the future, I guess, as you type. For such inputs, it's really useful.
So it sounds like Nuqs probably has like the URL is more of like a side effect, and then it's internally tracking the state. So those things like keep updating quick, right?
Exactly. Yeah. The URL remains the source of truth, but it's the eventual source of truth. On reads, the URL is always wins. But when you write, you have this temporary optimistic state update that happens while the URL update request is being queued and pending. So we have to track this optimistic state as well. But you have this, because Nuqs uses a use state kind of like API. And so you have the value and a function to change it, a state updater function. So the value is always instant, so you can connect it to controlled components. But the URL itself, as you say, is a side effect. There's a few use effects in there that deal with synchronization. Yes.
I just want to call out that you have a really good article about this on your blog, the Beware the URL Type Safety Iceberg. I thought this is a pretty fantastic read.
It's a summary of a talk that I gave at React Paris in March, and I'll be giving again in React Advanced London in November, 28th of November. It's like, what are the dangers that you don't really see with URL state? Because I saw this happen with Redux, with Zustand, with state management in general. You give people a tool and they will try and put it absolutely everywhere throughout their application because it feels magical. But when you try it the first time, it's like really nice. But you have to bear in mind there are some constraints to the URL in terms of size, in terms of time, as I said, in terms of a lot of things. And these things, this article and these points is like the accumulation of what I learned with this project, of the things you probably should not do with URL state. And so I want to be able to give people a sort of backstop against, you can do this, but be aware of these issues and limitations.
So kind of keeping in line with that, pushing things to the limit. I've seen you tweet about this a little bit, is you want to give people the ability to ship Nuqs enabled components to NPM and kind of like have this state management solution, like kind of completely outside of the host app's control. I'm interested if you've like explored that more and if you would recommend it.
It's not really outside of the host app's control. It's sort of a universal interface or abstraction layer on top of your components. So the great thing about React, and the thing that made it scale, I think, is the encapsulation system. You have a component which contains presentation, styles, and behavior. So within one component, you can describe all these things. The content, the HTML that you generate, the styles with class names and styles, and the logic with hooks and effects and all these things. But these states essentially live inside the memory of that component, the memory representation of that component. So Nuqs, what Nuqs can do is extract that to allow it to live in the URL in a descriptive manner. So you describe the search params that your component will accept. You export those along with the component itself. And those definitions that you've exported along with the component, you can reuse in server side with loaders, or you can compose them with other things in your page description. You can actually have this declarative way of telling, I have a component that behaves, that interacts with the URL. Here is what it needs. Here is what it can do. And here is how you link to it. How do you generate a link to a component that you've imported, essentially? So you have this framework agnostic way of defining behaviors for URL state that you can embed in NPM components or in a monorepo, especially, for example, if you have like a shared library that you, like I've had clients who had that. They had multiple Next.js apps, for example, and they wanted to have one old React router legacy that they wanted to port to Next.js. And they had this monorepo of multiple apps, and they had one design system library where they could have used URL state with this unified interface. So they could have consumed those components the same way they consume generally React components. You don't really think about the styles or the HTML that's being rendered by a component. You just compose them. So the idea with Nuqs is to do exactly the same, is to make it composable to declare your search params behavior and make it framework agnostic so you can load it in all the frameworks that we support. I have a little thing that we can add to that clip.
Yeah.
So if you want to build actually a library that builds components with Nuqs, one thing that I would recommend is something that I actually need to write about, is to add Nuqs as a peer dependency. Do not put it as a direct dependency. The same reason if you were to embed React query, for example, or TestStack query in a library, you would have some context issues. So React needs to have the same context object reference throughout your application to be able to connect the dots. And so Nuqs uses a context internally. And so if you want to be able to use those Nuqs-enabled components anywhere, it needs to be using the context of the application that you're loading it in. So loading it in. So this is important.
Something I wanted to ask about before maybe digging more into the framework specific stuff. I was going through that blog post that I mentioned previously, and one thing that I've thought a lot about on my own personal site is the fact that there's a lot of link rot on the web. So it's like people change URLs, and the URLs that someone else is linked to or bookmark or whatever like no longer works. And something that I kind of always want to optimize for is just like making sure that things remain. And it's interesting that you've like tackled this as a first class thing, sort of acknowledging that if you're changing your query parameters, there's like this migration steps that you might have to go through. And so you have this like create URL migration task. Can you talk a little bit about like where that came from and how you see it used? And yeah.
It came from breaking URLs. Essentially, yeah. We had applications where we changed something and then we realized, oh, but then the old links that we've shared no longer work. It's a Tim Berners-Lee quote, cool URIs don't break or don't change. I can't remember exactly what it is. But you want to make sure that the contract that you have specified by using a given path name and a URL state and a hash or something like that, the whole URL itself still behaves the same way throughout the lifetime of your application. And unfortunately, it's very easy to break things because it's very easy to change things and not very easy to see what you've changed. So this is the thing in the article is not actually an API that Nuqs exposes. It's something that I have in mind that I want to build in the future. It's actually two parts. It's like visualizing the changes and having an automated way of declaratively describing those migrations once you do a change. It's very similar to what you can have in database migrations because it's exactly the same system. If you think of the URL as a immutable static database that you've sent out in the wild and your application as the application server that needs to connect to those databases, you have to run migrations to make sure that the logic that's inside your application can understand what's coming from those URLs. And so it's the same thing as database migrations, I think. So we need similar kinds of tooling for applying changes the way we do in a declarative manner, the same way we do migrations in SQL, for example. But it's not technically limited to URLs. It's a key value migration problem. You could have this, and I have had the same problem with Redis, for example. If you update the shape of a JSON object that you store in Redis, now you have to keep whichever versions are updated, and you have to run migrations, data migrations, not necessarily schema migrations, because there is no schema in a lot of key value stores. But you have to run data migrations on whatever you receive to make sure that you can convert it to something that your application can understand. And so, yeah, this is likely the next venture I will go into in terms of open source, because I really want to tackle this problem in a declarative, type-safe manner. Like, I've always been frustrated with the state of migrations in databases, and I think that because of time itself is a problem, because your application evolves through time, so you need to have a snapshot of every state of the schema that you have gone through time to be able to branch off. It's a bit like Git if you think about it. It's like you have to be able to branch back to a given point where you've been given a URL that matches that particular point in time of the schema, and be able to retrace your steps by rebasing or squashing, whatever. Yeah, I don't know if the Git metaphor works really well, but it feels a bit like that. You have every snapshot of changes, and then you have to be able to walk that graph somehow when you do those migrations.
You'd probably like Datalog, the time traveling database or whatever. There's a lot of stuff in the like the sort of closure world specifically, where they or Datomic is the database, sorry, but like Datalog is like the query language where they make immutable databases, and you can do like time traveling queries and stuff.